Hey, it's Christina from Studio SE, and I am going to show you how to use the ALH helper LPI to get a structural feature from a block. Let's look at this example. This is a pretty fun executable model of a smart oven. Like one that you can, control through an app on your phone. So there are a few different programmable modes. If your oven's like mine, though, there's way too many choices on it, and it gets really overwhelming, and you end up choosing to do things the manual way anyways. But in this model, I've just made a few different modes that you can choose from. On this BDD, we see that there is this smart oven, and we're displaying a couple of part properties. We have the oven itself, and then we have one of the modes, bread mode. And so each mode is going to have its own specific value properties for things like bake time and the bake temperature that you need to set the oven at. So what we want to do is go ahead and, based on the mode that we choose, take those value properties and assign it to the oven so it knows at what temperature it needs to heat up to and then how long it's baking after it heats up to that temperature. The program bread activity that does this is allocated to the smart oven itself. So when we do this and we're decomposing this program bread activity, this activity is going to basically have access to all of the features of the smart oven. So if we look at the activity diagram itself, we see that, we're assigning the bake time and bake temp to two variables, and you'll see how this does not work in a little bit. But we have the bake time and the bake temp of the bread mode is being assigned to A and B, and then we're transferring the results of A and B over to this target time and target temperature of the oven itself. So we see in the values compartment of the oven, we have a target temperature and we have a target time. So if I run this, we're going to see that we experience an issue. I'm going to run it a little slow. So we'll run it, and we're going to end up stopping at this particular action. And if we look in the console, it shows that reference error, bake time is not defined, tells you where in the expression body. And it's also not going to then be able to evaluate bake temp. So it's actually looking for this bake time and bake temp inside this smart oven block. And the smart oven block is not the one that actually owns those value properties. It's its part property that does. So we need a way to tell this activity that, hey, you need to go inside of the smart oven, search for its part property oven, and then that's where you're going to find those value properties. So we can do that through one of the ALH helper APIs. So if we actually do, let's see, I think it's ALH.getValue, the part property name, and then we put the structural feature in quotation marks. Let's do that. And then same for this one down here. Oh, let's see, those are supposed to be dots. Okay, I think that almost looks good except for my shaky typewriting. Okay, now let's go ahead and run this one more time. Oops, what's this saying? Move that guy over there. Okay. Now we should see that we'll end up having this bake time of 23 being transitioned over to target time and bake temperature of 450 transferring over to this target temperature value as well. So let's go ahead and run this now. There we go. So we see 450 is going over there, and we see 23 is going over there. So this helper API has helped us look inside of the smart oven to that part property to access that specific bake time and bake temperature, those structural features of this part property. I hope that's been helpful, and I hope you can use this in some of your own executable models.